Lesson, you're going to learn about ambiguous cases with triangles and different numbers of triangles that can be formed. Ambiguity means that the information given doesn't give enough detail to know certainly what's happening. Depending on the properties of a triangle that you're given, it's possible that you may be able to construct no triangles at all, or one specific triangle, or two different types of triangles. We're going to find out about these different scenarios through 6 cases that are possible for given values of an angle A, a side A across from angle A, and a side B. The first case is this one in this graphic, where A is a value less than H. Now remember, H is an altitude from the opposite side. H is a side that would form a perpendicular to this base. Okay, so if A were actually smaller than that, what we're going to see is that no triangle can be formed. Now, just before I get going on this, because of the sides and angles we're working with, we'll always be able to use this version of the sine law. Sine A over A equals sine B over B. And we're going to have angle B as an unknown. So solving for that, we will find sine B equals B times the sine of A over A. And therefore angle B is the inverse of sine, or arc sine, of B times sine A divided by side A. We're going to use this formula each time. So in case A, here's what I have. Arc sine of side B times the sine of angle A, which I've made 30 in this case, and side A. Now hopefully you remember from special triangles that the sine of 30 degrees is a half. So I have a half times 10 divided by 4 as my ratio of sides, and I'm arc sining that to get an angle. Half of 10 is 5. I end up with 5 over 4 arc sine. Maybe you can think for a moment about what that value might be, even without a calculator. Angle B is undefined. Y is greater than R, which is not possible. You can't have an opposite compared to a hypotenuse or radius in standard position that is bigger. Using our calculator, if we entered all that values, make sure we're in degree mode, first of all, and we want arc sine, I said 10 sine 30, close the bracket, divide by 4, and close the bracket again, and we will get an error in the domain. So this is your calculator basically giving that same message. So in this case, there are no triangles possible if A is less than H. Now, actually, I have even another thing I can show you here. This is made in GeoGebra, and I've taken a screenshot of it for the notes. But I'm going to move this vertex B, so the CB is fixed at 4, and you'll see that as I move it, it's not possible for it to join the vertex, a vertex down here, to make a triangle. So no triangles are possible. Okay, second scenario. What if A equaled H? Now in this case, H, if it were 5, you would have half the opposite to the hypotenuse, which does match the sine ratio for 30 degrees, if you'll remember special triangles. But let's work with the formula and see what the formula gives. Arc sine of 10 sine 30, this time divided by 5, and we know that the sine of 30 is half, so 10 times half is 5 over 5, and the arc sine of 1 is 90 degrees, which is a confirmation. We get one right triangle in this scenario. And looking at a GeoGebra file of this, you can see that if I move, if I take this point and move this point down, I form a right triangle. I could use the angle tool and verify that, but you can see it visually, I think. All right, that's case 2, A equals H. Case 3, well, what if A is a value greater than or equal to b. I think I've got my graphic backwards here. I think this should be 12 and this should be 10. What I'm going to get in this case, arcsine of, let me see, the side A is 10 and then sine of 30 and I divide by 12. Half of 10, 5 over 12 with arc sine. Let's do that on the calculator. And we will get, let's quit this, and we want arc sine of 5/12, or you can enter the unsimplified version, 24.6 degrees. 24.6 degrees. We get one triangle, and it's an obtuse triangle, because this angle here is going to be greater than 90. We have 3 more cases to look at. All right. Now, it's a bit more complicated. In this case, A is greater than H, but it's less than B. All right. And we're going to see what happens here. Now, arc sine again. This time we're entering the value of 10 sine 30 divided by 7, which is going to be arc sine of 5 over 7 if we're simplifying using that special angle again. And I already entered this on the calculator, but you can verify it yourself. 45.6 degrees for angle B. However, there's actually a second angle possible. So I'm actually going to call this angle B1. And I'm going to say this is triangle A, B1C. Now let me show you what that looks like. Case 4. All right. If I move this angle, this point rather, there is one possible triangle, A, B1, C. But keeping this side at length 7, notice that I can also have a triangle over here. It's still 7. This 10 value hasn't changed. This angle 30 hasn't changed. So there are actually 2 possible triangles for this. One triangle is right here. I'll call that B1. But the other one is going to be right over here, and let me call that B2. Now, what we get, because that's the altitude there, and this is the same length as this, is we have a little imaginary isosceles triangle, and this angle here equals this angle here. So this angle is the supplement of angle B1. So angle B2 is 180 minus 45.6, which is 134.4 degrees, and we actually have 2 different triangles. So this is an acute triangle, all angles less than 90, and this is an obtuse triangle. I would call that AB2C. And this particular triangle is really the most important one to be aware of in this lesson. This is the ambiguous case that happens, where there are actually 2 different triangles based on the information given. All right, case 5. We're almost there. What if A is a value less than or equal to B, like 8 and 10 here? Well, using the relation that we've been using for the other triangles, we're going to get 10 sine 120 over 8. Maybe you recognize that 120 is a special angle as well, and we know the ratio for that. It is, let me see, root 3 over 2. We can use our calculator, and if you'd forgotten that, that's okay. Just a little bit of practice for you. And the 10 and the 2 have common factors, so I have 5 root 3 over 8, but that's about as simple as I can make that. Still going to need a calculator to figure out the angle because angle B is still going to be ugly. So let's enter that on the calculator. 10 sine 120, 10 sine 120, let's close that bracket, and divide by 8 and close the next bracket. And we get, we get another error. So there actually is no triangle here yet again. 5 root 3 is actually greater than 8. So the y is again greater than r. Therefore, there's no triangle again. One more case. This time a is greater than b. Arc sine of 10 sine 120 over 12. Again, that's that root 3 over 2. You can reduce it. Now 5 root 3 is less than root 12, so I am actually going to be able to assess this value. And let's go find out what that is on our calculator. So it's 5 root 3 over 12 this time. And just quit out of this, and let's see here. I'll just put it in unsimplified. 10 sine 120 divide by 12 this time. Close the bracket, and we get 46.2 degrees. So again, in this case, one unique triangle possible. 6 different scenarios for ambiguous case.